1596, Japan. A 13-year-old kid walks into his first duel to the death. He wins. He goes on to fight 60 more duels. He never loses one. Miyamoto Musashi, arguably the greatest swordsman who has ever lived. At the end of his life, when he sat down to write his masterpiece, The Book of Five Rings, he didn't write about speed or power. He wrote about rhythm, Hyoshi. He argued that if you are in tune with your own rhythm and the rhythm of the world around you, you'll never lose a battle. Now, I'm not a swordsman. I'm a software engineer. In 2021, Sony was preparing to launch the first device of a new line of devices, the Link Buds. Sony came to my team with a very specific directive. 9 months, 2 apps, both platforms. That deadline was non-negotiable because the factory floor doesn't wait for your pull requests. 7 engineers, an immovable deadline, and a choice of technology that ended up defining the rest of the years of our lives until now. Oh, but I didn't properly introduce myself. My name is Sergio Carrilho, and I'm a tech lead at Sony. And today, I'd like to talk about rhythm and what it costs. The scars, the bets, the working software. Our story was shaped by 3 forces. The first one, the force that never waits, hardware. These are the factory deadlines, the prototypes that take ages to arrive. You don't control this force, you survive it. The second one is the force that catches up, software. Ecosystem, KMP, CMP, and all the tools that are always evolving but are never ready. You cannot rush this force, but you can shape it. And the last one, the force that holds organization, people. Your agile team, yes, but also the managers and stakeholders who have their careers on the line. Legacy that resists. You don't command this force, you earn it. 2 forces push and 1 force holds. For the last 6 years, we've been trying to find the rhythm between these forces. Now, let me take you back to 2020, 6 years ago. Our story actually started with Loketon, a location-based sound experience application for the Japanese market. The schedule was tight, the team was losing members to other projects. Experimented with KMP was a survival decision. If it worked, great. If it didn't, 2 or 3 weeks lost, we were in trouble anyway. And it worked. And that gave us the courage to bet bigger. A couple of months later, that happened with autoplay. The idea, headphones stream high-frequency sensor data to the companion app, which has to figure what you are doing, commuting, walking, running, and automatically play the right content, music, notifications, weather. You see, for the LinkPad series, our design philosophy was to eliminate friction, not reduce it, eliminate it completely. So just picture this. It's morning, you are at your place, you put on your headphones, and you walk out the door. And automatically, your commute playlist starts playing. You don't touch the phone, you don't open the application, 0 interaction. Magic to the user, but a nightmare for the engineer. To do this, you needed high-speed BLE communications, consistent background processing on both platforms, and a UI that was able to keep up with the real-time sensor data. We had 3 requirements for this application. Number 1, iOS and Android. Number 2, background execution. Without the UI being open, the app should work. And number 3, we wanted to keep using our existing knowledge. We were an Android-strong team. That's what we had. We went looking for candidates. We found some, but they didn't really satisfy our 3 requirements. But then there was one, still in alpha. It was not even called KMP back then. Kotlin native, KMM. the ecosystem was thin, but the expect actual mechanism was a perfect architectural fit. We have a framework we use for every new technology adoption. 4 points: use case fit, ecosystem, tooling, and experimentation. I will come back to this later, but the point here is that KMP passed. Barely on some points, but it passed. And critically, if it failed, the fallback was just to do iOS native and just keep the Kotlin code for Android, which is the thing we would have done anyway. So the downside of trying was lose 2 or 3 weeks and do the default thing. But upside was massive. One code base for everything, all our business logic. And so we made the call. We chose alpha. And that was the first bet. Now, let's get into the trenches and talk about those three forces. Let's start with software, with hardware, the force that doesn't wait. Remember, Sony ships physical products. So when I say that the factory deadline is immutable, what I mean is that it's literally manufactured into existence. The factory has a release date, and hardware is going to be released on that date. It doesn't matter if the software is ready or not. And hardware, it moves in waterfall, which means that for you to request a firmware change, you need to do it in months in advance. Prototypes that take months to arrive. You are building against a timeline you cannot control. And this is exactly what we wanted to do. Accelerometer, gyroscope, and raw sensor data streaming in high frequency to the companion app. This is dozens of hertz, more than 25 packets per second, continuously, non-stop, bombarding the application. And the companion app had to figure out what you're doing and react in real time to that. So originally, we wanted to do all of this context computation on the headphones themselves, but the power and memory budget didn't allow for it. So the architecture flipped. All the heavy processing was sent to the smartphone and the companion application. So the hardware dictated the software, not the other way around. And when we were building the BLE protocol, there were no prototypes, there was nothing. This happens quite frequently with first-generation products. So we had to get creative. This is an Arduino on my table. We are programming the first bits of the software. So cool. Things like this is what I love being an engineer. So how do you build for a timeline you cannot control, for platforms with different rules, using a technology still in alpha? You build walls. This is our architecture. If you are familiar with hexagonal or onion architecture, you will recognize the pattern. In the center, you have the business logic, the shared logic. This is old KMP for us. And in the outer layers, you have the platform adapters. The core doesn't know or care about the outer layers. It just processes data. And in the core, we built a shared state machine for all the communication flow. Scanning, connecting, disconnecting, streaming, everything. So you have the single source of truth for all the communication, and you let all the platform adapters handle the wiring. And between the core and the hardware, and the Bluetooth hardware, we built ComLibs. This was built in collaboration with the hardware team. These are GATT-based communication libraries, one for Android, one for iOS. These are built to conform with each platform rules. So the core never touches Bluetooth, never. So what happened is that once, when the hardware guys changed the BLE protocol, we didn't have to change the core, only the libraries. And for this, KMP's interface-based mechanism was the key here, because it allowed us to define the contract once and let each platform deal with its own chaos. Use case fit, that's point one in our framework. Sensor data streaming through interface-based adapters to the core. That's why KMP fit for us. Not because it was the greatest platform, but because it solved our specific problem we had. And that fit is what kept us going when things got hard. Lesson number one, when the data pipeline starts on the hardware, the constraints are not obstacles. They're the blueprint. They're the architecture. So this was a scar and the bet that came from it. And this was hardware. It's rhythm set by factory floors. Now let me tell you about the other force, the one which never stops moving, software. So we had the architecture, BLE was flowing, and the hardware was holding. But then the software said no. This is a Slack screenshot from our internal Slack, okay, with translation now. So people, they were kind of puzzled, actually. What happened is, in those days, the iOS runtime was strict if you wanted to share data between threads. There was this thing called the old memory model and the freezing mechanism. So you wanted to share your object to another thread, you had to freeze it, making it immutable forever. You forgot to freeze it, and then tried to access it, bam, crashed. You froze it, and then you tried to update it, bam, crash. It was a minefield. The fix was on JetBrains schedule, the new memory model. But as we've discussed, the hardware doesn't care about that schedule. So we were left with three options. Option number one, wait for JetBrains. Probably the best option, the safest, but the timeline was unknown. Option two, do the proper way back then and use the freezing mechanism. We tried it kept crashing, and the debugging was brutal. Option number three, go against one of the first things you learn in mobile development. Never put heavy work on the main thread. Just ignore it, just shove high-frequency sensor data, measure everything, and take it from there. And that's exactly what we have done. But we didn't just close our eyes and do it. No. We measured everything. Frame drops, UI responsiveness, memory load, battery consumption, you name it. We've done dozens of internal releases and measured the crash rate in Crashlytics. We even increased the frequency of the sensor data just to bombard and just to stress the main thread. And we released it. And the result, zero. Zero main thread-related issues in production. The book said don't do it. The data said it's fine. And eventually, when JetBrains released the new memory model, we migrated. But by then, we had already been releasing stable software for years. Not years, for months. But actually, let me show you. So what I have here is my iPhone here. OK, so it's connected. OK, all right. So this is the original autoplay, the app from 2021 running on the main thread. What I'm going to show you here is that I'm going to connect my headphones with this beautiful head, and I'm going to walk, and let's see if the guy on the picture updates on real time. I have to tell you something though. Like, this place is full of radio frequency interference, so this is the worst possible place to be making this demo. But let's check it out. Okay, I think we got it. So it's gonna take, once I start walking, it's gonna take me like around 2 seconds to recognize that's deliberate, that's to filter for noise. All right, sorry. Got it, connected. Main thread, smooth shipped. Just in case it didn't work, but I'll show you later. All right. This was the software first debt. Now let me tell you about the second debt. So the new memory model was released. Software catches up. That's the nature of the force. But the question is whether the rest of the stack catches up with you. For the UI, we chose React Native. This was a pragmatic decision. We wanted a single code base for the UI as well, and we wanted to move fast. But fast has a cost. 4 different languages, 3 different IDEs always shuffling, and a build system held together by prayer. Really complex. Those were the things we knew, and we were OK with that because the benefits were very big. What we didn't know was that with every React Native upgrade, something broke, especially accessibility and the build system. We had to run lots of tests with every upgrade. We had to ship workarounds on top of workarounds. We were working for the platform, for the framework, and not the other way around. And just look at the code. This product was mainly business logic. And 30% of the product is UI or framework overhead. 30%. That's not product. That's tax. Eventually, something happened. In 2023, autoplay was working. Users liked it. So Sony made the strategic decision to merge it with the flagship audio application called Headphones Connect, and merge the whole thing and rebrand it as Sony Sound Connect. But this was a collision course of 2 different technologies. Sony Headphones Connect was a 7-year-old application built on top of old technologies, J to Objective-C, and native UIs, the old ones, XML and storyboard and so on. And autoplay, state-of-the-art KMP and React Native. We knew that the build system would not work. It would not survive. So we decided to part ways with React Native. And this gave us a new opportunity. So what if we think about revamp the whole UI and the architecture, the UI only? So we were left with 2 options. The first one was just go native. Jetpack Compose for Android, SwiftUI for iOS. The safest option, but we would have 2 code bases. But option B, maybe many people know already what's coming, right? Compose Multiplatform, the new kid on the block. Single code base for all platforms, for everything, including the UI. But the thing was, KMP for iOS was in alpha. Again. At this point, I think my team had a type. We kept falling for experimental frameworks. So, same playbook as always. Prototype fast, set checkpoints, define a fallback. If everything fails, just reuse the Compose code and Jetpack Compose for Android. And iOS, just port the thing and for SwiftUI. So the timeline. 2023 August, we run our first experiment with KMP. It didn't work. It was not ready for production. We shelved it. A couple of months later, it was decided that the Sony Sound Connect merger would go on, and the release date was set for 24 October. So we started designing the native UIs. KMP was not ready. But in December, we tried it again, and it looked promising. 2024 January, we merged CMP to the test branch. February, we merged it to the main branch. March, we did a huge accessibility audit. And Android, perfect. iOS and VoiceOver, just have a look for yourselves. Perfect. This is just jumping everywhere. At Sony, accessibility is non-negotiable. So we almost shelved it. But we set a new deadline for June. If the accessibility issues were not fixed, we would go native. We still had 3 months. We were pretty sure we could do the whole iOS thing in 2 months, so all good there. But we were watching the community. We were watching the conversations. We knew something was about to happen. Maybe a beta was coming. And May 23rd, on a blog post by JetBrains, Compose Multiplatform 1.6.10 for iOS was released. And it fixed all our showstopper issues. This release was incredible. So we could use it. But of course, we already knew this. Because we were tracking the GitHub, it had been released there, we tested it, we knew it would work. So we knew we could use it. There were a couple of things we wanted to do that there were no official libraries available. But this is where the community is really helpful. It got us started for everything. Libraries like Lyricist and Voyager got us started. Eventually, the official libraries caught up. But this is a great ecosystem. Official and community libraries pushing each other forward. That's really helpful. So the CMP bet worked. But winning the bet and shipping it inside a 7-year-old application are two different things. This is Sony Sound Connect. It has 4 tabs. How much of the application did we need to change in order to ship CMP? 1 tab. When you enter that tab, you are transported to a completely different world. Fully composed multi-platform world. It's 1 application, it's 2 paradigms, and the user never notices. What we did is that we put autoplay as a module, and you zoom out, and it's all KMP and all CMP. And between the autoplay and Sony Sound Connect, the boundary was a shared kernel. This is a concept from domain-driven design. It's a clean interface. It took us only 0.2% of the whole autoplay code. This made the cost of integration 0, almost 0. And just look at the language distribution. So recently, I showed you this, right? Just look after the migration. "94% Kotlin, no JavaScript, TypeScript, or just, we could only focus on doing features now. So you have also 6% of Swift, because we wanted the Apple Music experience to look as native as possible. But it's all Kotlin now. That's so nice. So we learned to ask not whether the technology was ready today, but if it would be ready when we need it, and if we can track the signal. Ecosystem, that's point number 2 on our framework. The community is the ecosystem. And the commit frequency was our signal. Lesson number 2, don't just read the changelog. Read the commit frequency. More scars, more bets, working software. The software had its own rhythm, sometimes slow, messy, but it always catches up. Now let me tell you about the third force, the force that holds organization. So everything I showed you now, the BLE architecture, the main thread bet, the migration, these are all engineering problems. but usually the hardest part are people. At Sony, we are very lucky because engineering is in Sony's DNA, and since its founding. I mean, the founders themselves, they had engineering backgrounds. So how we work is that engineers, they set the managers, they set the direction, and they trust engineers to execute and to build stuff. But trust is not a blank check. It has to be maintained continuously. So just imagine, I go to a product manager and say, can we bet our flagship application that ships to millions of users on a framework that even the creators called experimental? No, that's risk. But if I go to her and tell her, can we experiment with a new technology that has a lot of potential, give us 2 or 3 weeks, and if it fails, it's fine, we drop it. If it works, great. That's okay. No one's going to say no to that, right? Especially if you don't mention that it's the 3rd experimental framework you pick up in the last decade. But so we didn't ask to adopt KMP, we asked to experiment with KMP. And that has been our playbook since then. We structure every major technology adoption as a time box experiment with specific checkpoints. We would walk in those checkpoint meetings with our stakeholders, and we would show them what we built. We didn't show them slides, we didn't show them like estimates, but working software. And at the same time, our CI/CD pipeline was distributing the same software to them so they could test it and give us feedback. One good example of this was one of the main feature of autoplay. It's called Where to Play, where you put on the headphones and the music starts playing. No friction, no interaction, nothing. So when 2 months after the merger was decided, we walked into that checkpoint meeting and we showed them. This was not a pitch meeting. It was a demo with working software. It was with unit tests ready to ship. And they liked it. And eventually, that feature shipped exactly as it was. We didn't change anything. At every inflection point, the same playbook. That's why the hardware work bet. That's why the CMP bet worked. Not because we were right, but because we had a way to prove it. Experimentation, that's point 4 in our framework. Nothing gets adopted without a prototype that proves real value. But I want to be honest with you about something here. The story I've been telling you looks like a progression, right? Alpha to stable, messy to clean, React Native to compose multi-platform. That's true. But the reality is a little bit messier than the narrative. You see, Sony Sound Connect still has a lot of legacy code. And this is based on J2 Objective-C. It's shipping to millions, it's stable, but it's a completely different parallel ecosystem running alongside KMP. And J2 Objective-C, 3 releases in the last 5 years, that's the ecosystem telling you something. So we are migrating methodically, module by module. And we have one rule. It's just touch it when you need it, not because it bothers you. So if it leaks into the architecture, if it blocks some new feature, or if it adds maintenance cost, just refactor it right away. But if it's a stable module that doesn't change, just leave it. It's an asset for now, because we're going to strip it all. So if I stood right now and told you that we have migrated most of the code, that would be a lie. Software is messy. I think you guys know that. And admitting that messiness is what makes the success credible. Meanwhile, KMP is evolving at Sony. We're doing AI libraries, theming libraries, sensor libraries. So what started with 7 engineers and an experiment is slowly becoming the way we are developing software at Sony. Lesson number 3, The best thing we've done for our organization was to be honest about where we were. Not where we wish we were, not the version that looks good, but where we actually were. Honesty is a feature, ship it. The scar was trust, the bet was honesty, the working software spoke for itself. So that's it. 3 forces, 3 lessons. The constraints are the architecture, read the commit frequency, honesty is a feature, ship it. So, what did 6 years of scars and bets produce? Let me show you. The autoplay experience is fully now integrated into Sony Sound Connect. That experience targets 12 hardware devices. The whole Link Bud series that has the sensors, all the new headband flagship devices, including the one just launched 2 days ago. If you didn't check it like you should, it's really nice. And even a speaker. This is a single source code for all of these devices. We are shipping now to millions of users, globally, in many languages, iOS and Android, continuously. And our release cycles have been for 1.5 years, 8 weeks, non-stop, always pumping. And the people managing the whole CMP code and most of the KMP code are 6 engineers. 6. Not a dedicated Android team, not a dedicated iOS team. In every place I've been, every organization doing native, it takes at least double that number. And Sony Sound Connect recently won an IF Design Award, which proves that the technology didn't constrain the product, it enabled it. But numbers are abstractions. Let me show you the real thing. So what I have here is, okay, there's the iPhone here. Okay. And I have an Android here. Okay, all right. So the iPhone there and the Android here. Let me connect these devices. So this is the purple one. Let's connect the purple one to the iOS and the creamy one to Android. Let's open Sony Sound Connect. Okay. So just check what happens when I connect. It's so cool. Okay, let's take it from the case. Okay, it's connecting to the iOS first. Did you see it? Did you see something change? Yeah, exactly. So let's do it with Android one. So okay, just because it's cool, let's do it with an unscripted one, the pink one. Let's see if it works. This is the Link Buds fit. Okay, we're doing bets, not gambles. So, okay. Cool. The whole application theme changes according to the hardware. This is the hardware controlling the software, and this is a small KMP library we made that is being used by lots of modules internally. So let's check it out. Okay, let's enter into the scene one. So I set this place to be the gym, just to give like a nice animation. So see both platforms, same interaction. Let's try to set the gym again. And for example, let's open the maps, register for map, for example. Android, iOS, different stuff. All same behavior, all same code. This is the back one. Okay, let's try something else. This is the machine learning feature. Okay, disconnect here. So exactly the same UI, exactly the same workflow. It's a single code base. So last time I showed you an an application that was barely 1 year old. This is what it has become. So what did 6 years taught us? So I told you in the beginning about this framework. You have seen it operate across 6 years and on 3 major tech decisions. So let's see each point with proof behind it. Let's start with use case fit. We adopted KMP because it solved our specific problem, which was sensor data streaming through interface-based adapters to the core. We did it when it was the alpha. Maturity doesn't compensate for a bad fit. It never has. Alpha just worked just fine for us. The second one is ecosystem. The community is the ecosystem, and the commit frequency was our signal. It might be yours too. Tooling. JetBrains owning both the tooling and the language was a structural advantage for us. We've seen in this Kotlin Conf in the keynote, JetBrains is always evolving the language. When the tools and the language evolve at the same pace, the developer experience compounds with every release. And experimentation, this is the one that ties everything together. We structure every bet as a time box experiment with a known fallback. That's why we call them bets and not gambles. Because documentation tells you how a framework is supposed to work on the real world, experimentation tells you how it works in your world. 6 years we've been still using this framework for many other technology adoptions. So yeah, this is the story, and Sony, headphones, Bluetooth, migration still going. Now, let's zoom out from Sony and from headphones. So your force that never waits might be some competitor launch, might be some contract that is expiring next month, or even some sales deadline, Christmas sales or Black Friday. It's something you cannot control. Your force that catches up, software, might be some AI tooling you are considering, or some refactoring you are postponing, or even some new framework you are thinking about adopting. Maybe Compose Multiplatform? And people, the force that holds is always people. Always trust, always working software instead of slides. But frameworks don't win duels. Let me finish with the story. Musashi, 60 duels, undefeated. And he wrote about rhythm. Rhythm tells you when, but he also wrote about something else, crossing. He described the moment a warrior reaches a ford, which is a stretch of sea, and has to cross. You study the tides, you study the weather, you study your ship, and you go. Not because the conditions are perfect, but because you've done the work. You cannot cross a ford by halves. KMP didn't win because it was the most mature experience, the most mature framework out there. It wasn't. It didn't win because it had the largest ecosystem. It didn't. It didn't win because it was the safest option. No one in their right minds would tell you it was the safest one. It won because we studied the conditions, we chose our moment, and we crossed. Kotlin Multiplatform was our fort. You too have your own forts. We all do. The forces around you are moving right now. So study the conditions, and when they align, cross. Thank you.